Hello to everyone. I am Rabia Bilgicu, an assistant student at Smart Cities and Digital Ecosystems Lab. I sincerely welcome you to the seminar, which will be given by Professor Dr. Awais Rashid. This is the fourth of the seminar series organized by the top at the Smart Cities and Digital Ecosystems Lab. The talk will take around 45 minutes. Approximately in every 2 weeks, we will have distinguished speakers all around the world. To introduce our invited speaker today, I first give the word to Professor Dr. Mehmet Akşit, who is the head of our lab. Thank you.
Okay, so I think we can start, right? So thank you very much for all coming here. And thanks especially to Awais Rashid, Professor Awais Rashid, whom I have worked for a long time together. Very nice projects, very exciting trips, very exciting topics. Professor Awais Rashid is a professor of cybersecurity at University of Bristol, where he has the cybersecurity group. He is director of IPS-RC Center for Doctoral Training in Trust, Identity, Privacy and Security in Large-Scale Infrastructures, and Director of the National Research Center on Privacy, Harm Reduction, and Adversarial Influence Online. His research interests are in security of physical systems, software security, and human factors. He leads projects as part of the UK Research Institute on trustworthy interconnected cipher physical systems, UK Research Institute on socio-technical cybersecurity, the Digital Security by Design Hub Plus, and the Petrus National Center of Excellence in Cybersecurity of IoT. He leads CyBOC, an international effort on developing a cybersecurity body of knowledge to provide interdisciplinary foundations for education and training programs. I'm very excited to have today and welcome Professor Rashid to give his speech. Thank you.
Thank
you.
You
You can
very
share
much.
Your slides.
Yes, thank you very much, Mehmet, for the invitation, for coming and speaking to the group in this seminar. It's a pleasure to be here. I hope that you can see my slides at this point. Is that visible?
Yes.
Okay. So, as Mehmet said, I have interests that overlap in security of cyber-physical systems, software security, and human factors. And today I'm really going to talk about the last two of those and how they come together. So I'm going to talk about why Johnny doesn't write secure software. Johnny being your typical software developer. Before we go on to that, I should also note that this is really collaborative work with several colleagues at Bristol and other organizations. So it would be inappropriate for me to just claim all the credit. I haven't listed everyone because I have a number of papers that I refer to, and the colleagues who contributed those papers are noted there. And the work has also been funded by grants from the Engineering and Physical Sciences Research Council and the National Cybersecurity Center. Now, if you're not familiar, probably you are, the title of the talk and this research project that we have been doing for quite a few years is effectively an homage to Witten and Tiger's paper from almost 20 years ago, well, over 20 years ago. So they wrote a paper back in 1999, which was titled "Why Johnny Can't Encrypt," and this was a usability evaluation of PGP. And they went on to show how users found it really, really difficult to configure PGP and hence send encrypted email. And the challenges they faced, not because PGP was itself not a good scheme, it's just the way users were unable to use it effectively caused many problems. Around about the same time, and Adams and Angela Sasa wrote their paper called Users Are Not the Enemy, where they went on to show how users struggle with using passwords in authentication, why they end up writing them down, why they end up using weak passwords, and it's because of the cognitive load that users experience, but also because it interferes with their primary task, because they want to get the task done, and repeated authentication and repeatedly changing passwords actually creates problems in that regard. So the general issue with security has been that it often tries to fit the human to the task. And, we've all experienced it trying to log into systems using two-factor authentication or using, different types of devices like USB keys or other things to authenticate ourselves to various systems. And this is really what is referred to in human factors research as fitting the human to the task. And this is not the right way to go about it. So the argument that Witten and Tiger and Adams and Sessa were making was that really we need to fit the task to the human. We need to make security as easy and as possible to do so that it doesn't interfere with the primary task. There is a recognition that there will always be some cost associated with it. But if it becomes too complex, people want to get the job done, and they find ways around it, not because they are trying to be malicious, but because they are focused on the primary task. So a number of things have emerged over the last 20 years with regards to usable security. That security has to be usable, so it has to be effective. Can users achieve their goals? It has to be efficient. What resources are expended by users to do so? So if you have to spend a lot of time again and again authenticating into systems, you would spend a lot of your time doing that, and that's a resource drain. For instance, if every time you have to go and make a cup of tea, you have to lock your system and then come back and unlock it using perhaps two-factor authentication, that's quite costly. And satisfaction. What is the level of comfort and acceptability for you? So do users feel comfortable using the security mechanisms, or do they see them as a huge challenge for them, or they cause lots of discomfort? You may ask, why am I talking about users? Here we come to developers. What about developers? Okay, on the screen in front of you, you have probably recognized three major vulnerabilities: Heartbleed, Shell Shock, and Poodle, all arising from errors in the way in which particular features were implemented within software. So this actually leads us to ask the question, what about developers? Because developers often use, well, not often, all the time, use third-party libraries to actually build their systems, and they may misuse those libraries because they don't understand how to configure particular features. And this is actually very well known in recent years as a problem with cryptographic libraries. So what did we do? We actually went onto Stack Overflow. We looked at nearly 2,500 Stack Overflow questions and answers, because this is where often developers go when they have a problem. So we went and looked at nearly 2,500 Stack Overflow questions and answers relating to 7 major cryptographic libraries. And I say major, I mean the most used, mainly perhaps OpenSSL and Bouncy Castle are probably the bigger ones in that sense. But as you can gather, because OpenSSL is perhaps the most widely used, nearly 81% of the questions and answers that we found were relating to OpenSSL, and then there was a smattering of all the other. And we did an analysis of the kind of problems that developers face with regards to using these cryptographic libraries. So one of the problems that developers face is missing documentation. Okay, so this repeated again and again and again. So developers are trying to do something, they want to use a particular feature or mechanism, and there is missing documentation, or parts of the documentation are not clear in that regard. The other challenge that developers face is that in this case, you see here the developer is saying, well, I've tried several methods, but I can't get it to work. So they've tried something, something has gone wrong, but they don't know what. So they go on to Stack Overflow and they ask, hey, people, what's gone wrong here? Can you help me? Because I can't really figure it out. Then other things that developers find problematic is that they have found a feature and they are not sure if they should be using it for the for what they're trying to achieve. So they go on and they actually ask the question, well, I'm trying to do this thing, in this case with PyCrypto, should I use this or not? In some cases, well, in a lot of cases, there is genuinely lack of knowledge. So developers are not cryptography experts. If you are a cryptographic expert, you would understand quite a lot of the features of these libraries. But if most developers are not crypto experts and they're trying to use them as a way to achieve an outcome, for example, to store something securely or to send a secure message and things like that. So there is a lack of knowledge. The developers actually don't know how cryptography works properly. And then in some cases, developers are used to using these kind of libraries, and they're used to using one particular library. And now they come to a different library and they take their mental model from the original library and try to apply it to this new one. And they think it should work here, but it doesn't. Okay, so in this case, there are borrowed mental models that the developers bring their understanding from somewhere else. And then they go, well, actually, it should work the same way here, and it doesn't. There are other issues. We saw quite a lot of issues with regards to compatibility. So, the libraries just wouldn't play well with other libraries or other things that developers are trying to achieve within their software. And then there were also build issues. So, particularly we saw quite a few with OpenSSL that the library wouldn't just build as the developers were trying to get it to work. So we looked at all these questions and issues that the developers were having, and then we categorized them. Okay, so at a top level, you can think of these as 7 top level categories. Okay, so the first one is usage issues. So the developers have found something that they think that they should be using, and they ask the question, should I actually use this? Okay, for this particular purpose. So let's say you're trying to implement a particular feature, and you look at a set of capabilities within a library, and then you ask the question, well, should I be using this? The other side of this is that the developer actually knows exactly what they need to use, but they don't know how to do it. So they go on and they ask the question, how should I be using this? Okay. There are system issues. I mentioned build issues. There are also performance issues. So sometimes developers are trying to do something, but the crypto library is a resource hog, and they have particular real-time constraints or any kind of performance constraints that they're trying to deal with. Then there is not knowing what to do. So as I mentioned, in some cases, there is actually lack of knowledge, but in other cases, the developer is actually trying to pass the buck. So the information is there, it's available in the documentation, it's available in example code and so on, but they still go on to Stack Overflow because they don't want to invest the time. So they pass the buck to someone else. They go, well, actually, can you tell me how to do this? Because it'll be quicker asking them. Okay, not knowing if the library can do what they want it to do. So I mentioned borrowed mental models before, but we also saw examples of unsupported features. So the developer would think that it should be doing something, but it actually doesn't. Missing information was the big category all the time. Missing documentation, clarity of documentation, looking for example code and not finding it. Okay, and then there is the other one, which is programming is hard. Okay, so abstraction, Mehmet and I were at the start talking about, working together for many years, and we worked a lot on abstraction as a challenge, right? And that still exists. So there are a number of abstraction issues. The abstractions are not really suited to how developers work and the way they would want to integrate them into their code. But also API misuse, so developers misuse the API. There have been big studies around misuse of the Android SSL API, for example, that has led to vulnerabilities in a large number of apps, and also, not understanding what has gone wrong. And then, as I said, there are compatibility issues that, the library doesn't work with other libraries, but also deprecated features. So in many cases, the developers were actually trying to use deprecated features, which they shouldn't have been using any longer. So this is what we looked at. And then we thought we need to do some analysis on this. Okay. So we went to this particular piece of work that Matthew Green and Matthew Smith did. shortly before we did this study, which they wrote a paper similar to Adams and Sasser, that developers are not the enemy, and they argued for need for usable security APIs. So they posited 10 principles for usability of crypto APIs, and it's a nice paper to read if you go and look it up. One was that the APIs have to have good abstractions. Okay, so they need to. Their argument was that one needs to integrate cryptographic functionality into standard APIs, so regular developers do not have to interact with crypto APIs in the first place. So if it's actually built into your other APIs, you don't have to go and then work specifically with something like OpenSSL. They have to be powerful. Okay, so they have to be sufficiently powerful to satisfy both security and non-security requirements. And this is really key here, because developers are also trying to focus on a particular task. They're trying to deliver the software and its functionality. And security is not all the core functionality that the customer wants. Okay, there is increasing awareness about it, but ultimately the customer wants the software to do what it needs to do. And hence, it shouldn't just satisfy security requirements. It should satisfy both security and non-security requirements in a powerful enough way. The API should be comprehensible. It should be easy to learn, even without cryptographic expertise. It should be ergonomic. So don't break the developer's paradigm. As I mentioned earlier, abstraction issues, developers trying to actually integrate into their systems and finding it very, very complicated to do so. Intuitive. It should be easy to use even without documentation. And there are now libraries out there that basically aim to be documentation free, so that when you look at the functions, you actually understand what they're trying to do, rather than having to go to a separate documentation to understand what they're doing. Failing, so it should be hard to misuse. So if it is incorrectly used, it should lead to visible errors. And this we often saw over the years with self-signed certificates, that developers test some of their software with self-signed certificates and then end up deploying it. Safe, default should be safe and never ambiguous. So if you are using just default parameters, then they should be safe parameters. There should be a testing mode. So you should be able to run tests properly as you would want to in a production setting. They should be readable. So ultimately, libraries also need to be maintained. So the code should be easy to read and maintain. So updatability is very important. And explained. So when there are errors, it should explain what the errors mean. And we saw quite a lot of that as to what's gone wrong here. And it should also assist with handle end user interaction. So when errors arise at the end user end relating to crypto functionality that has been integrated from the library, one should understand what exactly has gone wrong there. So we took Green and Smith's principle, we took our analysis, and we thought we should look at to what extent the particular problems that we are seeing here, relate to Green and Smith's principles, and to what extent the libraries actually do preserve the Green and Smith principles in that regard. Okay, so I'm just gonna run through this. So we did this analysis, and we identified where the libraries may not be meeting the principles posited by Green and Smith. Now, those of you who have done anything to do with software refactoring will recognize the term smells. If you have not, then code smells is a kind of well understood concept in software engineering. Martin Fowler came up with the concept, and the idea was that if you're actually updating your code or doing something with your code, you often have smells that indicate that your code is not very well modularized. Okay, and here is an example of Fowler's shotgun surgery. So he says you whiff this when every time you make a kind of a change, you have to make a lot of little changes to a lot of different classes. Okay, in this case, object-oriented programming. Okay, when the changes are all over the place, they're hard to find, and it's easy to miss an important change. Okay, so it really does look like a shotgun surgery. And that basically means that your code is poorly modularized, and you need to refactor it so that you can actually make the change in one place so that you don't have to perform this kind of shotgun surgery in the first instance. So we asked the same question, that if there are code smells, there are probably usability smells in the way that we recognize based on what the analysis of our data from Stack Overflow questions and answers in the light of Green and Smith's principles. So we identified 4 usability smells. Okay, so one is needs a super sleuth. Okay, so you whiff this when documentation is missing, unclear, or there is a lack of example code pertaining to how to use the library. So if developers have to become super detectives when trying to do something with that library, then that's a usability smell and the library needs to do something about it. Okay. The other is confusion reigns. So you catch a smell of this when developers are designing and prototyping their programs, and they just really have to spend a lot of time trying to work out whether it is the right library to use, how to start using it, what are the features, and so on. So if it causes a lot of confusion in that regard, then there is a problem. Okay. The third one is it needs a postmortem. Okay. So the developer has used the library, but something has gone wrong. Either they have used the library incorrectly, or they are struggling to work out if it is an issue with the library itself, and they just don't know. So they have to do a postmortem to really try and work out, rather than easy to understand what the error is, where the problem is, whether it's something they did or whether it's something within the functionality of the library. And the last one doesn't play well with others. Okay. So this occurs when the library just won't build, won't integrate with other libraries and build systems, or is a resource hog without providing a clear explanation as to why. So we did this work, and we thought, okay, we now need to look at actually how developers consider security as they go about developing their software. And in that regard, we did another study where we looked at the mobile app ecosystem. Okay, so if you think about it, this is a kind of a high-level view of what a mobile app development might look like. You know, a developer may set up their way of working, so which is their IDE, their integrated development environment. They may write and test some code. They may have problems. Okay, so they go and solve those problems. They may say, you know, again, here, understand what this code does wrong. So what has gone wrong here? If they have a problem, how do they go and test it? Who do they trust to fix the problem? Given that it's a mobile app ecosystem, they need to think about monetizing. Should they charge for it? You know, or should they use an ad library? They have to release. They have to think about the kind of license clauses they want to put into their releasing. And then there is a cycle because they have to update the app. Okay, so those were the kind of big tasks we thought we should look at and see how developers actually consider security when they go through doing that. Okay, so we set up a study. We gave developers, we recruited developers online. We gave them some tasks. So we gave them a simple selection of top 3. We said, well, you're setting up your IDE. What would you select when, you know, as your top 3? And of course, in this case, choosing the static code analyzer with security checking rules would be your, you know, best security choice, followed by bug spotter, which does some, you know, security problem spotting as well, and so on. So we gave them a kind of a top 3 task. Okay, in that sense. We also gave them a piece of source code to fix, and there were 3 pieces of source code they could choose from. One was a security concern where passwords were stored in clear text. Okay, one was the performance issue with an inefficient sorting algorithm, and one was a readability issue where, you know, things were, you know, poorly formatted. And we said, well, you know, there is 3 of these things. Your boss has asked you at 5 o'clock you're about to go home. Which one would you pick to fix? We also asked them where would they seek help if they had a confusing API, for example, like a crypto API. You know, would they read the API's official documentation? So this was a sort task, you know, and in this case, that would be the most secure option because there are other studies from other research groups that have shown that actually that is the best source of information. Or would they go to an online resource like Stack Overflow, where again, studies have shown that the quality of the answers is not always very high? Whom would they seek testers from? Again, another card sort task. Would they send it to a specific user group for testing, which is a proper, more effective way of doing that? Or would they publish it right away and just rely on feedback where the problems occurred? We asked them How would they choose an SDK? Again, it was a card sort task. So in what order they would consider them. Of course, incorporating as many ad libraries blindly is not a good idea, although developers do that because they have to monetize. And on most app stores, you struggle to get people to pay $1 for your app. And but selecting specific ad libraries, depending on their required permission, of course, is the more secure choice. And we also asked them what kind of a license agreement would they choose and how would they prioritize, and if there is a prohibition on reverse engineering or benchmarking, then that actually stops more ethical security analysis on applications, and that is prohibitive from a security standpoint. So we asked developers to undertake these tasks. This was an online study. We recruited 44 developers, and this was the outcome. Okay, so in most cases, the developers did choose. Half of them chose a security solution for setting up an IDE. Nearly half of them chose a security solution when looking at the code task, and same for building a license agreement and an SDK. But very few thought that actually when they went to seek help on a confusing API or when seeking testers, that had a security implication. However, we also asked developers to say why they chose what they chose. Okay, and that's where things get interesting. Okay, so only 14% of them actually chose a security solution with a security rationale. So they explained that they were doing it for a purpose that was underpinned by security. Okay, for an IDE. Only primarily in the case of fixing the source code, most developers had a security rationale for choosing their source code. In some cases, people had security rationale, but they actually chose a non-security pathway. Okay, again, we saw that very little security rationale underpinning choosing any help with confusing API or seeking testers, again, with regards to advertisement, SDK, and so on. So we further analyzed what the developers told us in this regard. Okay, so we analyzed where there was a security rationale and a security solution, but there was a security rationale and then they chose an other solution. Okay, so one of the things that we saw prevailing was that, trust in other developers. Okay, so the developer would say, well, I'm actually choosing this because I believe in other developers doing the right thing. Okay, understanding permissions is important. We saw that with regards to SDKs, where they're saying, well, actually, if I understand what this library is trying to do, then that's quite important. The good thing is that we've been saying now for quite a while that people should not roll their own crypto. Okay, and this message is getting through. So the developers who chose the security code fixing task, they did say, well, don't roll your own crypto. You should be using this library or that library and so on and so forth. Okay, and similarly, input sanitization, that your SQL injection, that again, that message is getting through. People are talking about, well, I need to do input sanitization here. It's also good that developers who chose a security rationale and a security solution said, well, actually, Bug Spotter helps me spot issues, or static analysis helps me spot issues. They also noted that storing passwords in plain text was not a good idea. And we saw at least the first 4: trust in other developers, understanding of permissions, don't implement your own crypto, and doing input sanitization. In the other part as well, where people chose a non-security solution or another solution, but a security rationale. These people also talked about, don't assume that users are predictable, don't test by yourself, and be careful with personal data. But then they didn't go on to choose a security solution. And then there were some who actually chose a security solution but gave another rationale. This wasn't a clear security rationale, or just wrote something very, very, very brief, which didn't really give us much explanation. So what were the kind of things that came up? Okay, and we analyzed the comments that we got back from the developers in this regard, and developers do care about their users. So the kind of things that we saw was, I don't want to put my users at risk with weird permissions. Okay, in case of the licensing agreement, they talked about the fact that they prioritize on the basis of how extortionist or evil the clauses would feel to them as a customer, as the consumer. Developers also don't want to bother other people too quickly. So they were avoiding dealing with others at times. So they said, well, I want to be solving the problem, but without being needy. So I would try to read the documentation and try to find a solution on my own. or first I'll use the resources I can without the help from other people because their time is important too. All about the flow. And this is where we come back to the point about fitting the task to the human or fitting the human to the task, because they want to be in a flow when developing. And if things keep on getting in the way, then they would not find that very, very productive. Okay. And in some cases, they just went for the easiest path. Okay, so one developer said, well, I chose this code block because it was easier to do. The others had too many notes and documentation to read and understand, and I didn't want to do it. We then did a follow-on with this. So we took, we reached out to developers on the Google Play Store, following proper ethics permission and a GDPR compliant emailing service, to reach out to them and ask them if they would actually fill a short survey for us. And we asked them the questions that the security of my app is impacted by the code I write, the external SDKs I use, whom I involve in testing, what sources I go to for help, set up my development environment, and the license my software is released. Okay, and we saw similar reactions to the kind of in-depth study that we had done before. We managed to get 274 developers to respond to us, and primarily, again, in the code-related tasks, developers thought that was the most important for them, but not enough towards testing or sources for help and other things. There is a little thing here to note that, for example, here we asked about external SDKs, and in the first study we asked about ad libraries, and that may have impacted the difference that we see here. Okay, if you so this was published at ICSI a couple of years ago, so the details of the study are available there. Okay. And since then, we've been doing a number of kind of follow-on pieces of work. But one of the things that we then went on to ask is, actually, how do we actually get developers to think more about security? Okay. So one of the questions that we asked was, well, if we always talk about writing specifications, okay, and we say, well, if you write your specification, it helps you write better software because you're clear whether you write it formally or informally, you model it in UML, or you write a formal specification. It's up to you. So the question that we asked was, well, does the act of writing a specification for a piece of security sensitive code lead to developers producing more secure code? Okay, and I won't go into the details of the full study because I've got only about five minutes or so left. But you can read the full story, full paper in Proceedings of ICSI last year. And we basically asked this question: if we did this, would developers actually store passwords more securely? Okay, we recruited 138 developers from Prolific, an online platform, if you're not familiar with it. And we assessed the results of the task that we gave them. So we asked them to, store passwords, and we gave them a set of tasks to do. And we then assessed the results using criteria from Nayakshina, this group in Germany, doing really interesting work in this area as well. And they have a storage assessment criteria that draws upon the NIST criteria, okay, to see whether, their password storage approach actually met the approach of a good strategy. Okay. And the answer is that, yeah, it kind of makes a difference. Now, you would ask me the question, what is a specification? So we asked the developers to just write anything. They could write it, formally. They could draw a box and line diagram. They could write it in plain text. Okay. But we asked them to write down. So we asked half of the participants to write down a specification before they did the task. And the other half, we just asked to do the task. But we also asked the other half at the end, did you write a specification of any kind? And if they said yes, we moved them into the specification group, because we couldn't assume that, some people may have written something without us prompting. Okay. And the answer is that there is a significant effect, but the effect size is actually tiny. Okay. So there were a number of observations that we had from the results that we got. Okay. And the worry that we had was that the hashing choices that people made were very concerning. Okay, so for example, people actually used SHA-1, and things like MD5 rather than going for more secure mechanisms such as bcrypt. Okay, the other interesting thing was that some of them, because this was an online study and actually this was done during the pandemic, some of them, of course, went on to online sources and copied. But of course, we went and checked. Okay, so and there were a number of participants who actually went and copied the solutions verbatim. Many to Stack Overflow, but some also went to GitHub and other places to copy their results. But results were copied verbatim. So there was an issue here that if they didn't pay attention to what the post said, if the post started off by saying this, and this, and this, and this, they took that and didn't read till the end to see that it said this is a bad way of doing it. Okay, so they copied an insecure example because the poster was saying, well, this is not a secure way of doing it. And then they go on to describe the secure way of doing it, but they didn't reach that far. They quickly copied and moved on. Okay, so again, the group that copied, they scored significantly higher. But again, the effect size was very, very small. And there were other things that we saw. So for example, one of the developers said, I've been working as a software engineer for 8 years. I have developed authentication systems for our clients hundreds of times. So I've come to learn the best practices of doing so, but only scored 3 out of 6. Okay, so we saw a number of these examples across the board that often developers had an overconfidence in their ability to do this. Okay, so having looked at all of this, earlier I said that, our message of don't roll your own crypto seems to be getting through. Perhaps we should also be telling people not to roll their own authentication too and use mechanisms such as OAuth, for instance, to provide authentication services. So before I wrap up, I wanted to just sort of comment on sort of where we are going next with this. So at the moment, we've been doing all this work and we are doing some more work in this area at the moment, but we're also starting to look at hardware security mechanisms. So at the moment, there is a big program in the UK in which we are also involved. So the Cherry, which is the capability hardware mechanism, came out of Cambridge and is being adopted by ARM for their new security architectures, is very much a kind of a focal point at the moment. But ultimately, Cherry will provide protections against some of the kind of memory management issues that we see in languages like C, from where security problems arise. Okay, but ultimately, developers are going to build on top of Cherry. Okay, and one of the things that we are actually looking at is, what kind of usability issues will developers face? I'm not saying these are the issues they will face, but we know that these are the issues that developers face with, say, crypto APIs. So will we see similar issues? For example, is missing documentation going to be a big problem? Okay, will developers actually understand what kind of capability are they getting from the underlying hardware and how that impacts their software? Will there be issues around, performance, and for instance, and things like that? And all of a sudden, they will have to change their mental models of how do they do memory management, and to what extent would that prove a challenge? Okay. So this is something that we are looking at as part of the Describe Hub, which Mehmet mentioned at the very beginning. It's the Digital Security by Design program. And our focus in here is to really look at how the advantages of the secure hardware architecture will flow through the software ecosystem all the way to end users. And I'm biased, but I think developers sit at the heart of it, and software engineering sits at the heart of it in that sense. So I started this talk early on by saying that security has to be usable. It has to be effective. Can users achieve their goals? It has to be efficient. What resources are expended by users to do so? And they have to have satisfaction. What is the level of comfort and acceptability for users? But if we replaced users with developers, it still holds. Can developers achieve their goals? What resources are expended by developers in doing so? And what is the level and comfort for developers? I also started by saying, don't fit the human to the task, but fit the task to the human. Again, don't fit the developer to the task of security, fit the task to the developer. In this regard, we've done an interesting analysis across various studies that have been done in this area. and the paper came out last year, where we talked about the fact that people talk about developers as enemies or users, but they're actually collaborators. So if when we are designing these kind of security mechanisms, if we work with those kind of users of APIs, the developers who are the users of APIs, to try and understand what their problems are, and if there is more of a engagement between library developers and library users in that sense, then that may go quite a long way to addressing some of these issues. Okay, I'm going to stop here. Thank you very much for listening, and happy to take some questions.
Thank you very much. I really enjoyed it. It was an excellent talk. So if there are questions, please, you can ask.
Mr. Rashid, I have one.
Yes.
Mr. Rashid, you mentioned that we should use APIs instead of using libraries without documentation, and these APIs should be easy to use, right? By using API, you mean that these APIs should be online, like for example, Auth0 authentication applications?
Yeah, so that's what I meant, that for things like, for example, authentication, not all systems require you to use to roll your own password management and password storage mechanism. Okay, so if something like OAuth and a service, an online identity provision service is a way to go, then why not do that? Okay, but there is still quite a lot of systems where people are just writing their own, authentication mechanism and their own password storage and hashing and salting. And in some cases, yes, that would be needed, but in a number of other cases, that is not necessarily needed. So yes, I mean, the more we can take away this issue where developers are constantly having to roll their own solution all the time, and with cryptographic libraries, you've got sort of good implementations out there that you can use. I mean, there are still usability issues with them, but similar to that, you can do that also for things like authentication.
Okay. So my question is that so for some applications, you cannot use the internet actually, and for some companies, you need to use intranet.
Mm-hmm.
And do you have a solution that can be used as an API for the intranets without?
No, I wouldn't. I'm afraid. I think the thing I would say there is that's absolutely a case where you have to build something bespoke. But then the question becomes is, what is it that the developers are using to build that kind of intranet mechanism, and how that is being utilized. But again, if there is a in-house deployed authentication mechanism, you could use that. But no, I mean, that is a very different example, and that's a very specific case, which I would say, you won't be able to use a kind of a third-party service into which you can throw something and get something back.
Okay, and one more thing. So if we decide to use the APIs that are online, does it mean that we actually delegate the security to a third party? And like many applications can do that all over the world. And if there is a major security issue in that application or an unreachability in that API, it would mean that then we are vulnerable, or at least we cannot use the API, and then what can we do against that?
I think that's an excellent question, and I think this comes to the kind of your fundamental challenge in terms of relying on any kind of third-party service. I think with regards to security assurances, there are assurances that you can get from particular service providers in that sense. But you're absolutely right. If you're relying on a third-party service to do something and then it goes down, all of a sudden you can't authenticate and enter your system. Okay, and then what do you do? But then you, of course, build kind of redundancy, so you're not reliant on just only one set of credentials. You can use kind of multiple identity providers in that sense. So if any of those are valid, you actually go and do that. And if you go onto some websites, for example, you will see that they will say you can log in with Google credentials, or you can log in with Facebook credentials, or you can log in with this other third credential as well, and things like that. So there are multiple ways to kind of try and solve that, but you can build some redundancy into the system. But you're right, it creates other types of challenges. Okay, and you also have to think about, for example, the reliability and the security assurances that third party can provide to you.
Thanks a lot.
Okay, are there more questions?
Well, there is one in the chat, and there isn't a rule of thumb. In regards to the question was, how can we be assured about using a specific library without being a detective? Is there a simple rule of thumb? Not really. I mean, there are some libraries that claim to be more user-friendly. So OpenSSL is quite kind of, notorious for being very hard to use. But again, depends on how you are using it as a user. But there are other libraries out there that aim to be much more user friendly. But really, we don't know how user friendly really they are. So I'm afraid it's not an easy answer, easy question to answer. There isn't one. There isn't a rule of thumb, I'm afraid.
Okay, thank you very much. I have a number of questions, or actually two. Okay. And I would like to get your opinion about it. So you made an excellent analysis of the security problem, if I may call like that. Your slide on usage issues and system issues, not knowing what to do, and so on. And then you have actually look at the software structure or the architecture, and all kind of things like smells. And interestingly, of course, developer is involved, and you have done some sort of analysis of the personality of the developer, if I may call it, and then some sort of psychological analysis. And then we see actually that psychology of the developer is very essential, and even more essential than maybe formal specifications, which would, of course, hurt some people in the science, as we know. And that's very interesting. So what we can maybe say is that by educating people, by training, and maybe we should change the way how we teach software development education and software engineering, probably we can do a lot. Maybe there is the problem. So maybe university professors are to blame in software engineering. Does it make sense to you?
Mehmet, you're on to my favorite subject, I'm afraid. So, okay. So I think the thing is that I have a bit of a challenge with the term secure programming. Okay, because I think all programming should be secure. And I think part of the problem is that, and I mean, I'm not pointing the finger, we're all as a education ecosystem, perhaps, responsible for this, that people come in, we teach them to write code and don't really say to them, you have to start writing this in a secure way. You have to start thinking about it in a secure way. And then we say to them, well, now that you've sort of learned all these kind of strange ways of doing things, actually, they're not really the right way of doing things. You have to do it in a more secure way. And then they have to unlearn and do it again. Right. So I think, there should be only one thing. It should be secure programming. We should start by talking to people about the issues that arise. The other issue that tends to arise is that a lot of the universities have moved away from teaching languages like C at the moment, and I'm not sort of condoning C in any way. It has its issues, but one of the things is that when you learn languages like C, you learn the challenges of memory management and vulnerabilities that arise from there and things like that. If you never encounter them, and in due course, you go and start using C, but you've only ever used a memory safe language, you end up in a situation where you go, well, actually, it should be doing like this, but it doesn't, right? And as a result, it creates all sorts of challenges. So I think it starts very much, at that point. I completely agree with you. I think if we start with that principle that we are going to teach people to program in secure ways, okay, then it should at least help mitigate some of the issues as graduates come out of universities.
So actually, if you generalize this, so when I look at the slide on user issues, system issues, not knowing what to do, not knowing if it can do, and so forth. And if we generalize security to quality, software quality, and I may conclude, and I want to, of course, get your feedback, that it is a compositionality problem or composition problem. Because when we look at software composition in general, if you abstract it to the level of composition, all the issues what you are relating to can be seen also as software composition problem. So if I may, when I look at your slide, and actually I see some kind of software compositional way of thinking, which of course I know you have this thinking. So it is actually an issue of quality, and the quality is largely the problem. The quality problem is like largely the software compositional problem. Is this right?
Yeah, I mean, I can only agree. I mean, we've discussed this in the past many times, and in this case, the challenge arises from developers trying to compose security properties with other properties in their system, and yes, they don't understand where the kind of issues arise as a result of that composition, or that composition is not easy to do in the first instance. And we see kind of loads of these kind of issues. So yeah, no, absolutely. I think that's definitely the kind of, I think to me at the heart of it lies two things. One is abstraction and the other is composition. Okay, so
exactly.
Do we have the right level of abstraction, and do we have good composition mechanisms? And unfortunately, the answer is no in both cases.
Mm-hmm. That's my hidden agenda always. Okay, thank you very much, and for the presentation, and on behalf of the persons, my group, and so I really enjoyed it. It was an excellent talk, also very educative, I think, and hope to see you in person again. And I'm working now on especially emergency management, automating the earthquake management systems. And there also a lot of security issues, because we try to gather information from households, but when you gather information, then there is, the problem of personal information and protection of personal rights.
Yeah.
So, but the earthquake is a terrible thing. So it kills people. So it's you seek a way to get information without harming people's privacy. So if this is also your interest, so we may work together in the future. So absolutely. I mean, we cannot get away from security. So actually, the topic of critical systems is also very much related. So thanks again, and greetings to Rosanna and everybody I know in your group. Bye bye. Thank you.
Okay, thank you very much all for having me. Thank you.